Alright, this is your video for 11.4 inscribed angles. Now in 11.5 we add some more angles to this, so it's really important that you understand an inscribed angle. So the inscribed angle theorem from your vocabulary grid says that an inscribed angle is equal to half the measure of his intercepted arc. So you have all that vocabulary right here you need to make sure you understand. Basically, an inscribed angle can go through the diameter, or it can be part of the diameter. It can go around the center of the circle, or it can totally go away from it. It doesn't matter. All that makes an angle inscribed is that its vertex touches the circle. So an inscribed angle. And then if that happens, the angle is half the measure of the arc. Okay. So here on this first one it says find the measure of angle PRU. Well, here's PRU, so then you follow his angle out, and the arc that subtends that inscribed angle, it's inscribed because R is sitting on the circle, is 118. So then all I have to do is I know that the angle is equal to half the arc. So I want to know this angle is half of 118. So this angle is 59 degrees. It's really easy when you understand the theorem, but you have to make sure you get this before we add on to it. Okay, then this theorem can be used in reverse. Find the measure of arc SP. Well, SP is this arc right here. He subtends this angle that's 27. So if I do 27 times 2, then I will figure out that the measure of that arc is 54 degrees. All you have to do is remember that the arc is the big guy because he comes to a point, he gets smaller to get to the angle. Okay, you try C and D using that other picture. Alright, so the measure of arc ADC is 270 and the measure of angle DAE is 38. Okay, so an art student turns in an abstract design for his art project. Find the measure of angle DFA. Okay, so I'm going to zoom in on this picture now. So there is a lot going on in this picture. We have lots of inscribed angles, lots of arcs, all that kind of stuff. What we know is that this angle right here is 33 degrees. Then this arc over here is 164, and you'd say that corollary 11.4.2 that says if multiple angles go to the same arc, then those angles will be congruent. So if this angle is 60, or this arc rather is 64, then that means this angle is 82, this angle is 82, and this angle is 82. So that might not help us, all three of those, but maybe one of them will. And at the point where you have these circles that you have no idea what you're doing, just fill in as much information as you can, and eventually something will come up. Okay, this is a problem that when I do this in class, it takes us a long time and working it out and trying several things to figure it out. But since this is just me, I guess I'll show you. So, what you need to focus on is right here. This triangle right here, we used the inscribed angle theorem to get that this angle was 82. Now we are going to use the triangle sum theorem to tell us that I've already used 33 and I've already used 82. So this angle right here has to be 65. Angle DFC has to be 65. And then if I want to get to DFA, I can use the old linear pair theorem and do 180 minus 65 is 115. So the measure of angle DFA is 116 degrees. Now what you could have done, this is not one that we remember too often, but instead of doing triangle sum and then linear pair, you could have done the you could have done the exterior angle theorem. Remember that one is, I think that one's from, oh sorry, I'm writing off the paper here. That one I think is from chapter 5, and it says the exterior angle is equal to the sum of the remote interior. So we could have done 33 plus 82, and that would have given us the 116. So either way, either triangle sum and linear pair together, or exterior angle theorem by itself, and you can justify and still get to 116. Okay, then we have 11.4.3 that says that if an inscribed angle subtends a semicircle, if and only if it is a right angle. And that one makes sense because that one's based off the inscribed angle theorem. If this is a semicircle, then that's 180 degrees, so it makes sense that its inscribed angle is half of that is 90. So that one kind of follows from the inscribed angle theorem. And that's going to help us with example 3. So this is a diameter. I know that because x is the center of the circle. So I know that this is 180. So I know that 5a plus 20 is equal to 90. So 5a is equal to 70. So a is equal to 14. Now this problem actually does say find a, so I'm good to stop there. If I had plugged it back in, I would get 90, so that wouldn't do me any good. I just want to stop at a. Okay. This one, example B, actually goes off that same corollary that the art project does, because angle LJM this arc LM subtends that angle, and it subtends this angle. So if they go to the same arc, then those two angles have to be congruent because they go to the same arc. So 5b minus 7 has to equal to 3b. So negative 7, whoopsies, negative 7 is equal to negative 2b. So b is equal to 7/2. Now this one doesn't say find that. This one says to find the measure of angle LJM. So I'm going to go and plug that in. 5 times 7/2 minus 7. 35/2 minus 14/2. 21/2. There we go. So the geometry you need to get out of this is these two angles, they belong to the same arc LM, so they must be the same measure. Set them equal and do your algebra business. Alright, let's see what's next. Okay, this one belongs to the last theorem of this section, theorem 11.4.4. And that says if we have a quadrilateral inscribed inside of a circle, and all inscribed means is that each vertex touches the circle once. So K, J, H, and G are all inscribed angles there. So if we have a quadrilateral that does that, then what I can know is the angles that are across from each other are supplementary. So all chapter we've been just setting everything equal to each other, so you need to fight that urge on this one. They're not equal to each other, they're supplementary. So what I can get out of that is 6b plus 20 plus 3b plus 25 has to be equal to 180 because the two opposite angles are supplementary. In a minute, I'm going to start writing where you can actually see me, and that'll be awesome. Okay, so combine like terms. 9b plus 45 equals 180. 9b is equal to 135. B is equal to 15. Now it doesn't say find B, it says find all the measures, so then I'm just going to go and plug that back in. So 150 minus 69 is 81. 3 times 15 plus 25 is 70. Now this one doesn't have a measure, but I do know they're supplementary, so 180 minus 81 is 99. And then 6 times 15 plus 20 is 110. Or I could have just known that these two were supplementary, so that would have to work out 110 and 70. Either way. Okay, pause here and try B, the very last one. Same idea. Okay, so this one I set 33 plus 6x plus 4x minus 13 equal to 180 because the two opposite angles are supplementary. That gave me x is equal to 16, so I plugged that in all around 72, 51, 108, and 129. Okay, see you tomorrow.